Okay, we'll start our discussion session for dynamics of ship motion for today. We'll first review the student lecture by linking the ship motion to its respective figure. So we will start with yaw motion. Where do you think yaw would be going?
Top left.
Top left, okay. First one. Okay, next let's do sway. What motion does sway represent in this figure?
Lateral displacement.
Sorry?
Lateral.
No, c'est
So where does it represent? Yes.
bottom left.
Bottom left, okay. Okay, sir, let's do pitch. Yes.
Front view. Top.
Front view.
Yeah, top.
Top
Yeah.
one?
Yeah, yeah, yeah.
No, top right.
Top right? Oh, okay,
yeah.
okay, okay. Okay. Number 4, roll. What does roll represent?
Middle.
Very fast. Okay. Okay, number 5, heave. What does heave represent? The right one?
Right.
This one? Okay. Then third will be here. Okay, so the answers are these two should be changed. So, but anyways, so these are the 6 motions that we learned from the student discussion, the student lecture. But our first question is, what do you think is the most dangerous motion for a operating ship? But in this case, let's think of a rigid body ship. So do you have, if you have any opinions, feel free to talk about it. Yes?
I think the rolling motion is the most dangerous.
Okay, do you have any reasons for it?
Yeah, because it can cause the boat to sink.
Because the boat will sink.
Yeah.
Don't you think that yaw and pitch could also sink a boat?
Yeah, but it's more likely that the roll happen.
Yeah.
Compared to pitch.
Oh, okay.
Waves.
Do you have any other thoughts about this question?
Yes. Heave.
Heave?
Yeah, it
Okay.
can be dramatic if the boat is overloaded and the water can submerge the boat.
Okay. Okay, any more opinions? Pitch? Okay, why do you think it's pitch?
Other things that the rolling and hip are just moving the trend of that this is rotating. If you're developing pieces also very dangerous for ship like this.
Oh, okay, okay. So, anyways, thank you for the opinions. So we have discussed there are lots of motions that could destroy or submerge a ship. And we learned in the student lecture that there are many ways to mitigate the rotating or translating motion. For example, we have a bilge keel for stabilizing roll, and water tanks are also for roll and stabilizer things. So there are lots of measures to reduce the motion of the ship. And the second question is, how do you think the motion of a ship or the effectiveness of the stabilization methods are tested?
We put the boat in a huge swimming pool, and then with artificial waves.
So you mean a real size boat?
No, a model.
Model ship. Okay. Okay. Do you have any more ideas? Yes?
Put them on the real boat and share in the PhD.
Okay. Yes.
We can do a simulation.
Computer simulation. Okay.
What software?
Okay, so anyways, these are very good opinions. So the two most prominent methods that I thought was CFD and model testing. So for model testing, like the figure on the left, we have a ship modelization. So we have like a towing tank or like a tank that simulates the ocean's motion. So we can test model ships in these kinds of situations, or we have CFD simulations. We can do all the calculations in the computers. So my other question is, how accurate do you think the results of this model test are? Do you think it is accurate or not?
I think the CFD maybe is accurate, but then you should trust more the model testing because there are external factors that maybe are not included in the CFD.
Also, modeling is much more accurate.
I would say this.
Oh, okay. Okay, so any more opinions about this? Yes.
We meet the non-dimensional like numbers. I think simulation is more. I mean, the modeling is more.
Okay. So similar results as what she said.
I
Okay.
mean, the point tank with the ship model is more.
Oh, the modeling. Yes. Okay. Okay. So we discussed about like how CFD and modeling results could be compared to actual results. So the next question is, what do you think are the pros and cons for each method compared to like testing in real conditions, like he just said?
The safety is cheaper. And the ship modeling costs a lot of money and time.
Okay, so any other opinions? Okay, so we'll just pass. Okay, so until now, when we talk about the motion of a ship, we talk about a rigid body motion. So a recap is a rigid body is defined of when it's really an idealization of a deformation of body. So the deformation of body is neglected when we talk about rigid body motion. So any distance between 2 points in any points of the ship is constant. So, but in real world, the ships we construct or like rubber boats and such ships, they are not rigid. They deform and they can like change shape according to the waves and external loads. So my second question is about what would happen if we generalize? So what do you think that rigid body ships are more resistant to roll or other ship motions compared to flexible bodies? Yes.
Yeah, I think when it's flexible, it can absorb more energy, so it will be more stable.
Oh.
Okay. Any other opinions? This has no answer, so you can really talk.
I think it's unstable.
Flexible is more unstable.
Yes.
Do you have any reasons for it?
The body can change it, so if the wheels center can be moved, and it is not good for express the position of the mechanism.
Ah, okay. Do you have any more opinions? Yes.
I think there is not a lot of difference in the experimental part because the weight is the same even if the shape changes. So the gravity is there. The buoyancy changes, but I don't expect that there is a huge deformation to have a big change. So I think there is not a lot of difference.
Okay. So any more opinions? Okay, so
qui
it was nice discussing about the second question.
est pas la mode
And
de-
finally, in the last part of the professor's lecture, there's a part about ship autopilot. So I want to discuss about autonomous ships and its effects. So the first is that there are lots of technology regarding autonomous ships. And I want to discuss the pros and cons of implementing these autonomous technology to our ships. So I want to see it in a cost perspective, safety perspective. If you have any opinions about it, please tell me.
Of course, for cons, it's expensive.
Expensive,
Yeah,
okay.
to have autonomous ships.
Les deux, ouais.
Hein?
Les deux.
Attends, je
C'est cheap.
Do you have any more opinions?
Do we need to talk about the difference between two kind of boats, or? What are we
The
talking
pros
about?
and cons compared to like ordinary ships
Okay.
and autonomous ships.
Okay.
Yes. Yes. No?
I think it will be cheaper because there will be no need to hire tools.
Okay.
For safety, example for warship, it is better to have autonomous ships to for if,
Life, c'est bien.
yeah, you could save life
Right.
because there is no crew inside if there is a
Explosion.
explosion or attack.
Or sink.
Okay.
And there is no human error in the autonomous ship.
Okay, okay. No more opinions? Okay, we don't have lots of time, so we'll just, this is my example answer. There's some of them are mentioned, but some of them are not answered, so you can check it out. So the final question of my discussion section is, since there are more and more AI control ships, what do you think, who do you think should be possible, who do you think should be taken into account when an AI control ship is involved in an accident? Who should be responsible? Sorry. There could be the owner, there could be the driver of the ship, or they could be the manufacturer of the ship. So who do you think should be responsible when such a accident happens?
I think it depends on the accident conditions. Like maybe
It depends.
sometimes, yeah, sometimes it's evident that it's the pilot's fault, but sometimes something in the algorithm turn bad, and then it's the manufacturer that can be responsible.
Okay.
So an investigation need to be done.
Any more opinions? Yes.
I think he's a predictor because if he sells autonomous chip, he don't need a driver.
Yes. So who should be responsible?
The predictor, the seller, not the bot.
I didn't get you.
The retailer.
What? Yeah.
The owner?
enterprise who creates the ship, the company.
Manufacturer.
Yeah.
Oh, okay, okay. Okay, so I think there were good opinions. So this is the end of my discussion section. Thank you for your opinions.
Thank you.
Thank you. 이거 그 정리